Part 1. Please find a quiet place to sit or lie and to listen to this audio. Once seated, close your eyes. Focus your attention on your breath. When you are ready, inhale slowly. Let the air fill your lungs. And then exhale slowly. Let the air escape from your lungs. Inhale again, and then exhale again. Notice how your stomach rises as you inhale and falls as you exhale. Rises as you inhale and falls as you exhale. If your mind wanders, don't be concerned. Just gradually shift your attention back to my voice. Part 2. Now shift your attention to your thoughts, emotions, bodily sensations, urges or memories, and attempt to categorize these experiences. So for example, if for a moment you think about all the activities you need to complete tomorrow, you could repeat to yourself, there was a thought. If for a moment you become aware that you feel sad or agitated, you could repeat to yourself, there was an emotion. And if for a moment you become aware of sensations in your body, such as your heart beating faster or a tingle in your leg, you could repeat to yourself, there was a sensation. If you feel compelled to drink or smoke something, you could repeat to yourself, there was an urge. And finally, if you replay some event from your past, you could repeat to yourself, there was a memory. So for a few minutes, complete this activity yourself. That is, decide whether you have just experienced a thought, emotion, bodily sensation, urge, or memory. Don't worry if you're not certain. Just guess if you're not sure. Part 3. Now, for a moment, open your eyes. Fix your eyes on something in front of you. Perhaps a sparkling window, a rickety chair, or a colourful painting on a wall. Then, while maintaining your focus on this object, shake your head from side to side, as if saying no. What does this object look like when you shake your head from side to side? Does the object also seem to shake from side to side? Or does the object seem to remain quite still? Well, for most people, the object looks quite still. Why does the object look still? Well, the object looks still because your eyes remain fixed on the object. So to illustrate, slowly shake your head to the left. When you shake your head to the left, your eyes shift to the right at the same time and at the same speed, effortlessly and unwittingly. Now slowly shake your head to the right. When you shake your head to the right, your eyes shift to the left at the same speed. Feel free now to close your eyes again. But rather than shake your head now, while seated, tilt your body to one side, perhaps towards the left. That is, tilt from your hips, so your left shoulder is farther left than your hips. Unsurprisingly, when you tilt your body, you do not immediately collapse to the floor. Instead, you can maintain this position for quite a while. Indeed, this task might seem straightforward. But actually, to balance yourself, you needed to contract a variety of muscles. Side muscles and many other muscles must contract at the right time, unconsciously and effortlessly. Otherwise, you'd collapse to the ground. Feel free now to sit upright again. So when you shake your head, how do your eyes know where to shift? And when you tilt your body, how do your muscles help you maintain balance? Well, a special system helps you shift your eyes and balance your body in response to these movements. This system is called the vestibular system. You might want to repeat this phrase several times. The vestibular system, the vestibular system, the vestibular system. So where is this vestibular system, and what does the vestibular system look like? And how does this vestibular system work? So part 4. To answer these questions, imagine you could peer inside the ear canal of someone else and see through their skin and bones. As you peer inside the ear canal, Initially you notice only dark space, but then eventually you'd see a series of organs, a membrane that resembles a drum, a series of 3 bones, each with an unusual shape, and finally a structure that resembles a snail called the cochlea. And these organs only help us hear. They do not help us shift our eyes or balance. They are not the vestibular system. However, immediately above the tail of this cochlea or snail, you notice 3 small semicircles, perhaps light pink or grey in colour. And each semicircle faces a different direction. For example, one semicircle seems to face upwards, and one semicircle seems to face forwards, and one semicircle seems to face to the side. Now, you don't need to visualise these semicircles exactly. You merely need to imagine 3 semicircles a few centimetres from the outside of your ear, called the semicircular canals. Now, attached to these semicircular canals are 2 more oval structures that resemble almonds, and these 2 almonds are called the saccule and the utricle. As you imagine these 2 almonds, repeat the words saccule and utricle. Saccule and utricle. You don't need to memorise these terms. Simply repeat the words saccule and utricle. Saccule and utricle. Part 5. So how do these structures help you shift your eyes and balance? Well, first, consider the semicircular canals. Imagine you can peer inside these semicircular structures. You realise these semicircular canals are filled with a thick fluid, like a stiff honey or a liquefied jelly. Furthermore, inside these canals, the membrane is lined with small tufts of hairs called hair cells. For a moment, imagine you could somehow insert your finger into these canals. You could feel the warm jelly surrounding your finger, and you could feel the soft bristles as you pass your finger across the small hairs jutting from the membrane. Now imagine the sequence of events that unfolds as you rotate your head from side to side or in some other direction. The semicircular canals will also rotate. For example, the semicircular canal that faced upwards no longer faces upwards. The canal that faced forwards no longer faces forwards. And as these semicircles rotate, the hair cells shift at the same rate. But the fluid does not shift as fast. The fluid seems to remain in place. And so consequently, the fluid will seem to bend the hairs to a different angle. Hair cells that seemed to stand erect before are now bent, and the angle indicates the direction in which your head had shifted. Imagine that your head shifts only slightly, bending the hair cells only marginally. But now imagine that your head shifts greatly, bending the hair cells quite prominently. And once bent, you can visualize these hair cells generating sparks of energy called action potentials. Part 6. Nearby, the 2 structures that resemble almonds, the saccule and utricle, provide a similar function, but rather than respond to the rotation of the head, they respond more to acceleration and deceleration of the head. Imagine that you can see inside the saccule and utricle. Like the semicircular canals, inside these almond structures, the membrane or coating is lined with small tufts of hair, also called hair cells. But furthermore, inside are small particles called otoliths. You can assume these particles or otoliths resemble small rice bubbles. As you visualize these small rice bubbles floating in the saccule and utricle, repeat the words otoliths, otoliths, otoliths. These particles or otoliths are partly composed of calcium carbonate, the same substance that forms the shells of eggs, snails, and marine life. Now visualize someone lunging forward suddenly or performing some other action in which the head suddenly accelerates or decelerates. In response, the saccule and utricle, the 2 almond structures, will accelerate or decelerate at the same rate, but the particles or otoliths are not connected to the saccule and utricle and therefore do not accelerate or decelerate as fast. Therefore, the particles or otoliths will bend the hair cells. Again, once bent, you can imagine the hair cells generate sparks of energy called action potentials. Part 7. So in summary, whenever people tilt their head, hair cells in the semicircular canals bend and send action potentials. Whenever people accelerate and decelerate, hair cells in the saccule and utricle bend and send action potentials as well. But to where exactly do these action potentials, these sparks of energy, travel? And how do these action potentials or sparks of energy shift the eyes and restore balance? Well, in essence, you can imagine an axon, like a hose, emanate from each hair cell. And these axons bundle together to form a cord called a nerve. And this nerve is part of the 8th cranial nerve. Well, what is a cranial nerve? And how many cranial nerves can be found in humans? Well, 12 main cranial nerves have been identified in humans. And each cranial nerve exchanges information between the brainstem, the bottom of the brain, and the body, usually the face and neck. For example, the first cranial nerve is a bundle of neurons that send information from the nose to the brainstem and back again. And the second cranial nerve is a bundle of neurons that send information from the eyes to the brainstem and back again. In contrast, the 8th cranial nerve sends information from the vestibular system in the inner ear to several regions of the brain: the medulla, the cerebellum, the spinal cord, and even the thalamus. And these regions then control the eyes as well as the muscles that regulate our posture.